Alright, so one of my favorite sections is balancing chemical equations, and that's where we're going to focus on for these next couple slides. So a couple things about your chemical equation. It's useful because they give you an idea of what's going to actually happen. Let me actually spell this correctly. Does it like me now? There we go. So if you're going to go in the lab and you're going to do experiments like you're going to do, it's useful to know like what's actually going to happen. Is there going to be an explosion? Is nothing going to happen? Is precious metal going to form? Is a toxic gas going to form? So that's one thing that's kind of useful. Remember that arrow is your separating thing. And then a big thing here you definitely need to remember is the coefficients. So when you balance equations, you're just going to write coefficients. So there's kind of like two steps to it. First, you figure out what are your reactants. You figure out what are your products. You write them. You balance or equations, whatever. And then when you're actually physically just balancing the whole reaction, you may only use coefficients. And coefficients are these guys out front. You can never change one of these subscripts. And it does give you kind of relative masses. So if you know how if it's like a 2 to 1, you need twice, however much the one thing weighs, you need twice as much of that weight versus another chemical in the reaction. Couple of the rules for balancing chemical equations. The easiest way is to figure out how many atoms of each thing are present on both sides and go from there. And that's what we'll do. Make sure you count them correctly. And then you're going to start inserting coefficients. And this is one thing where some people are really good at it. If you're good at like logic games, you're really good at Sudoku, you may just see balancing equations. And that's awesome. And they're almost kind of enjoyable in a sick way. Some of you, they will just not be your favorite things. Try and start with the most complicated ones first. If a polyatomic ion is on both sides, like there's a nitrate on the left and a nitrate on the right, you can act like they're one thing. You don't have to, but you can. And try and save your hydrogens and oxygens for last. They're all over the place. If you start trying to balance them, you're going to fix yourself 27 times in the process. And if it's taking you like 5 minutes to balance an equation, take a break. Probably erase all your work and start over, because it probably means that you're working too hard. There's something you're probably missing. And then again, when you're all done, make sure you count your atoms up and make sure you're all good. One thing here, just at the very bottom here, you may not change your subscripts. So we know that hydrogen gas is H2. He's in Brinkerhoff. We know that oxygen gas is O2 because he's in Brinkerhoff. And we know that water is H2O. So if this is the reaction you're trying to write, when you balance it, you can only come back and put numbers out front here. What you want to avoid is sometimes people come in and they say, well, I'm just going to slide a little 2 in. And they say, okay, this is how I'm balancing it because now I have 2 hydrogens and 2 oxygens. When you do that, you inherently change what the chemical is. So H2O is water. H2O2 is hydrogen peroxide. So you want to be very careful not to do that because you are essentially changing what the chemicals are. So what we would have to do to balance this is we'd have a 2 out front and a 2 out front in here, which we'll get to in a second. But just make sure that when you've written your formulas and you know they're right, you can only use the coefficients, and they're the guys out front. Alright, so our first reaction here this is a picture of it. We have zinc, which is just a pretty reactive metal. We have hydrochloric acid, and it's going to react to make zinc chloride and hydrogen gas. So 2 reasons that this is kind of a cool reaction. One, it releases hydrogen gas, which is flammable and explosive. So that's kind of nice. And second of all, zinc is a really reactive metal, and it's used a lot in our like Navy, because if we have those huge battleships and stuff, they'll actually line the hulls with zinc, because zinc will be reacted with and the actual like ship is left alone. So it's pretty cool that this common metal zinc is used. The first thing we have to do is we're going to have to write out our formulas. So I'm just going to leave a space, and we're going to have zinc plus. Now you have to remember all your formula writing. You can't forget that from the last chapter. So hydrochloric acid, something that starts with hydro means it's a binary acid. So it's going to be HCl. Hydrogen is +1. Chlorine is -1. So we're okay. Now, zinc chloride, zinc is +2. Chlorine is -1 from your blue sheet. It's an ionic compound. So we're going to have ZnCl2. And last but not least is we have hydrogen gas. Hydrogen is all by itself. He's in Brinkelhoff, so he needs to be H2. Now, you need to be able to write these formulas correctly. If these formulas are not written correctly, you'll never balance the equation right. So if you did not do well in the last test, this is not the time to give up, because you will only become further behind if you don't do this. Then what you want to do is we're going to just go through and say how much of each thing we have. So I have zinc to worry about, I have hydrogen, and I have chlorine. And I'm just going to get a pen here. So on my left side, I have 1 zinc. On my right side, I have 1 zinc. On my left side, I have 1 hydrogen. On the right side, because of the subscript, I have 2. And on my left side, I have 1 chlorine. And on my right side, again, because of the subscript, I have 2. And I said, for some of you, this is super easy and you love it, and that's great. Some of you, you're like, okay, I'm trying to keep up here. So just make sure, whichever group you're in, or if you're a mix, that you're working on this. Zinc is already balanced. Now my hydrogens and chlorines are off. So I have to say, what can I do? I have to put a number out front of here. What can I multiply by 1 to give me 2? And of course the answer is 2. So what I do is I put a number 2 out front as a coefficient. This 2 affects hydrogen and chlorine. So when you think about that, that reevaluates my whole thing. Now on the left, I don't have 1 hydrogen anymore. Now I have 2. And on the left, I don't have 1 chlorine. Now I have 2. And what you see is all my elements are balanced, which means that we did our job, and that's all you have to do. So sometimes you'll need 1 coefficient. Sometimes you may not need any. Maybe it's already balanced. So you just have to see what each individual thing needs. All right, next one is aluminum carbide reacting with water. It's going to produce methane gas and some solid aluminum hydroxide. So first thing, they tell us we have aluminum carbide. So let me just, Al4, C3. It's going to react with water, which we all know is H2O. Methane gas is one of our organics, and if you remember, methane meant 1 carbon, which is CH4. And the last thing we're going to make is aluminum hydroxide. This is an ionic compound. You look it up on your blue sheet. Aluminum is Al +3. Hydroxide is OH -1. So OH has to be in parentheses, and we're going to need 3 of the OHs because of balancing charges. Again, this is a step that should not take you a long time. You need to be able to write formulas to be able to do this, and it's an expectation. Again, if you cannot do this quickly and efficiently, then you need to practice more. All right, and we're going to just keep track of our guys. So we have aluminum to worry about, carbon, hydrogen, and oxygen. And if we look this on the left, remember, really what you're looking here is subscripts and stuff. So on the left, we have 4 aluminums. We have 3 carbons. We have 2 hydrogens. And again, oxygen, there's nothing after it, so there's just 1. On the right side, there's nothing with aluminum, so there's just 1 aluminum. There's nothing with carbon, so there's just 1. Now be careful because there's hydrogens in more than one spot. So we have 4 hydrogens here in methane. And then over here, because of the parentheses, this 3 distributes, just like in math. So I have 3 hydrogens here plus 4 more. Gives me 7 total. And if we're looking at our oxygen, it's just this one spot here. The 3 distributes, and we have 3. So if you look at this guy, this is kind of a pathetic one. there are no balanced equations, like no balanced ones. So you just start wherever you want to, probably with aluminum. So I definitely need more aluminums on my right side, so I'm going to put a 4 out front. That fixes my aluminum, which is great, but now remember, this is going to really mess up other things. And sometimes you just have to mess up other things to make them work. So this aluminum, this 4 affects my aluminum, but because he's a coefficient, he affects my oxygen and my hydrogen. So I used to have 3 oxygens, and I have to multiply that by 4. So now I have 12 oxygens. And same thing for my hydrogens. I have to do 4 times 3, which is 12. But there's also these guys right here. So 12 plus 4 is 16. So our aluminums are good. Our hydrogens and oxygens are pathetic. And that's okay. They're kind of like the ones we do last. So just kind of let that go. Let's fix our carbons. We need a 3 out front of our methane. That fixes our carbons. It messes up our hydrogens. So again, this 3 affects the hydrogens and the carbons. So I have 3 times 4 plus 4 times 3, which gives me a whopping 24 hydrogens. And then the last but not least, we have to fix these pathetic hydrogens and oxygens. So what we're looking at here is we have our hydrogens and oxygens. We say what times 2 will give me 24, and that would be 12. That fixes my hydrogens and that fixes my oxygens. So we're all good to go. Oh, I can't write. That should say 24. Sorry. If you don't need to write out the balancing like below, that's fine, but you need to make sure that you're checking it and making sure that you're actually balanced. So again, I'll pause and then I'll show you the answers to the next page, so these next ones, and then there's some that you actually have to get checked by the teacher. Alright, so here are your answers to 3 and 4. Again, make sure you probably worked with someone or whatever, but make sure you can get these. 3 was a little tricky because you had to you have to logic your way through it. You may have tried 2s at first, and if they don't work, you have to try the next thing up. Don't be afraid to, erase something and do try something different. There's not always one way to balance an equation, and again, you just have to keep trying them. And one thing you want to be aware of, I'm just going to make this up just to put it out here. If for some reason you would have gotten like a 2, a 6, a 4, and a 6 as your answer, you are technically balanced, yes, but you would lose a couple points because you're not the lowest one. And when you balance things, you want to be the lowest one. So just before you leave a problem, make sure that your numbers are as low as they could go, because obviously 2, 6, 4, and 6 are all divisible by 2, and that's how we get this 1, 3, 2, and 3. So just make sure that when you're balancing, that you really are getting that lowest ratio, because that's what you're looking for. On the next slide, I'll put it up, then there's a 3 that you need to write down and balance and get checked, and make sure that you can do them. Good luck.